Oracle database servers are the backbone of many businesses, responsible for handling mission-critical data and transactions. Choosing the right server architecture is paramount for performance, scalability, and resource efficiency. Oracle offers two primary server architectures: dedicated server and shared server. Understanding the nuances of each is crucial for DBAs seeking to optimize their Oracle environments. Dedicated servers operate on a one-to-one connection model, with each client process having its own dedicated server process. This architecture provides isolation and potentially higher performance for individual sessions. However, it can lead to increased resource consumption, especially with a large number of concurrent users. Each dedicated server process requires its own memory and CPU overhead, potentially straining system resources. Shared servers, as the name suggests, utilize a pool of server processes to handle multiple client connections. This architecture promotes resource efficiency by minimizing the server processes required to manage numerous client connections. Instead of dedicating a server process for each client, a dispatcher process directs incoming requests to available shared server processes. This approach reduces memory consumption and CPU overhead, making it ideal for environments with high user concurrency. Choosing the optimal server architecture depends on various factors, including the number of concurrent users, workload characteristics, and system resources. Dedicated servers are well suited for applications requiring high individual session performance or isolation. Shared servers excel in scenarios with high user concurrency, offering efficient resource utilization and scalability. Dedicated servers are the default configuration in Oracle databases, simplifying the setup process. When a client initiates a connection, the listener spawns a dedicated server process specifically for that client. This dedicated process handles all requests from the client until the connection is terminated. Configuring dedicated servers involves minimal effort, typically requiring no explicit configuration changes. The listener, responsible for managing client connections, automatically assigns a dedicated server process to each new connection request. This straightforward setup makes dedicated servers an easy choice for initial database deployments or environments with predictable, low concurrency workloads. While dedicated servers excel in simplicity, it's essential to monitor system resources as the number of concurrent users grows. Each new connection consumes additional memory and CPU resources, potentially impacting system performance if not adequately provisioned. DBAs must proactively monitor server load and resource utilization to ensure the system can handle the demands of concurrent dedicated server processes. Shared servers, unlike their dedicated counterparts, utilize a pool of server processes to handle multiple client connections. This architecture introduces several components that work together to manage requests efficiently. The key components include the dispatcher, shared server processes, and request queues. The dispatcher acts as a central coordinator, receiving incoming client requests and routing them to available shared server processes. It maintains queues for incoming requests, ensuring that each request is handled by an available server process in a timely manner. Shared server processes, as the name implies, are shared among multiple client connections. These processes pick up requests from the dispatcher's queues, process them, and return the results to the appropriate clients. Configuring shared servers involves modifying the listener and database initialization parameters. DBAs must configure the dispatcher process, define the number of shared server processes, and specify the request queues to be used. While the configuration process is more involved than dedicated servers, the benefits of resource efficiency and scalability often outweigh the initial setup effort. Resource management is a critical aspect of database administration, ensuring optimal system performance and stability. Dedicated and shared servers differ significantly in their resource consumption patterns, impacting how DBAs manage system resources. Understanding these differences is vital for selecting the appropriate server architecture for specific workload demands. Dedicated servers, with their one-to-one connection model, consume more resources per client connection. Each dedicated server process requires its own memory allocation and CPU cycles, leading to increased resource consumption as the number of concurrent users grows. This constrains system resources, especially in environments with high user concurrency. Shared servers, on the other hand, excel in resource efficiency. By utilizing a pool of shared server processes to handle multiple client connections, they minimize the overall resource footprint. Fewer server processes translate to reduced memory consumption and CPU utilization. This architecture is particularly advantageous in scenarios with high user concurrency, where dedicated servers would consume significantly more resources. The choice between dedicated and shared servers directly impacts how DBAs manage system resources. With dedicated servers, DBAs must carefully monitor server load and resource utilization, ensuring sufficient resources are available to handle peak concurrency demands. Shared servers provide more breathing room, enabling DBAs to optimize resource allocation for other system processes or accommodate a larger number of concurrent users without significant resource constraints. Optimizing server setups is an ongoing endeavor for DBAs, striving to extract the best performance and efficiency from their Oracle environments. Whether utilizing dedicated or shared servers, several practical tips can significantly enhance scalability and overall system responsiveness. For dedicated servers, one crucial optimization technique is connection pooling. Instead of creating a new dedicated server process for each client connection, connection pooling allows a pool of pre-spawned server processes to handle incoming requests. This reduces the overhead of creating and destroying server processes, improving connection establishment times, and reducing resource consumption. In shared server environments, tuning the dispatcher and shared server configuration parameters is essential. Adjusting the number of shared server processes, queue sizes, and dispatcher configuration options can significantly impact performance. Monitoring dispatcher queues and shared server utilization provides insights into potential bottlenecks and areas for optimization. Regardless of the server architecture, optimizing database queries and application code plays a crucial role in overall system efficiency. Poorly written queries or inefficient application logic can negate the benefits of any server configuration. DBAs and developers must collaborate to identify and optimize performance bottlenecks stemming from inefficient code or database interactions. Shared servers offer compelling advantages in resource efficiency and scalability, but achieving optimal performance requires careful tuning and monitoring. DBAs can employ various techniques to enhance shared server performance, ensuring responsiveness and efficient resource utilization. One critical aspect of performance tuning is optimizing the dispatcher configuration. The dispatcher acts as the central coordinator, routing incoming client requests to available shared server processes. Tuning the dispatcher's queue sizes, request dispatching algorithms, and process affinity can significantly impact how efficiently requests are handled. Another crucial area for optimization is managing shared server process counts. Having too few shared server processes can lead to request queuing and delays, while having too many can unnecessarily consume system resources. DBAs must strike a balance, ensuring an adequate number of shared server processes to handle peak workloads without over-provisioning. Monitoring shared server performance metrics is essential for identifying potential bottlenecks and areas for improvement. Tracking dispatcher queue lengths, shared server utilization, and request processing times provides valuable insights into the efficiency of the shared server architecture. DBAs can use these metrics to fine-tune configuration parameters, optimize resource allocation, and ensure optimal performance. While shared servers offer significant advantages, they also present unique challenges that DBAs must navigate effectively. Understanding common pitfalls and implementing preventative measures can help avoid performance issues and ensure a smooth shared server experience. One common pitfall is inadequate dispatcher configuration. The dispatcher plays a central role in shared server architecture, and misconfiguring its parameters can severely impact performance. Setting inappropriate queue sizes, choosing inefficient dispatching algorithms, or failing to optimize process affinity can lead to request bottlenecks and delays. Another challenge lies in managing shared server process counts. Having too few shared server processes can lead to request queuing and sluggish response times. Conversely, having too many shared server processes can unnecessarily consume system resources, potentially impacting other system processes. Finding the right balance is crucial for optimal performance and resource utilization. Monitoring and troubleshooting shared server environments require specialized tools and techniques. Traditional monitoring tools that focus on dedicated server metrics may not provide sufficient insights into shared server behavior. DBAs must utilize tools and techniques specifically designed for monitoring dispatcher queues, shared server utilization, and request processing times to effectively identify and resolve performance bottlenecks. Shared servers have proven their worth in numerous real-world deployments, showcasing their ability to handle high user concurrency and deliver exceptional performance. Examining successful case studies provides valuable insights into the practical benefits and potential use cases for shared server architectures. One compelling case study involves a large online retailer experiencing rapid growth in user traffic during peak shopping seasons. Their existing dedicated server architecture struggled to keep up with the surge in concurrent users, leading to slow response times and frustrated customers. Migrating to a shared server architecture significantly improved performance and scalability, allowing them to seamlessly handle peak traffic without performance degradation. Another success story highlights a financial institution processing a high volume of online transactions. Their dedicated server infrastructure was consuming a significant amount of system resources, limiting their ability to scale and accommodate future growth. Implementing a shared server architecture significantly reduced their resource footprint, freeing up resources for other critical system processes and enabling them to scale efficiently. These real-world examples demonstrate the tangible benefits of shared servers in high concurrency environments. By efficiently managing resources and providing scalable performance, shared servers empower organizations to handle demanding workloads and deliver exceptional user experiences. Selecting the appropriate server mode, whether dedicated or shared, is a critical decision for DBAs. A well-defined decision framework can help guide this choice, ensuring the chosen architecture aligns with specific workload demands and resource constraints. The first step is to thoroughly analyze the anticipated workload characteristics. Factors such as the number of concurrent users, transaction volume, and the nature of database operations play a crucial role. Environments with high user concurrency and transaction volumes often benefit from the resource efficiency and scalability of shared servers. Resource availability and constraints are another key consideration. Dedicated servers consume more resources per connection, potentially straining system resources in high concurrency environments. Shared servers, with their efficient resource utilization, are well suited for resource-constrained environments or scenarios where maximizing user capacity is paramount. Performance requirements also factor into the decision. Dedicated servers can offer higher individual session performance due to their dedicated resource allocation. However, shared servers can achieve comparable or even superior overall performance in high concurrency scenarios by efficiently managing a pool of shared resources. Shared servers stand as a powerful tool for Oracle DBAs seeking to optimize resource utilization, enhance scalability, and deliver exceptional performance in high concurrency environments. By understanding the intricacies of shared server architecture, mastering configuration and tuning techniques, and navigating potential pitfalls, DBAs can unlock the full potential of this versatile server mode. Choosing between dedicated and shared servers requires a comprehensive understanding of workload characteristics, resource constraints, and performance requirements. While dedicated servers offer simplicity and potential performance advantages for individual sessions, shared servers excel in resource efficiency, scalability, and handling high user concurrency. As Oracle databases continue to power mission-critical applications and handle ever-increasing workloads, shared servers provide a compelling solution for optimizing resource utilization, enhancing scalability, and ensuring exceptional performance. By embracing shared server architecture and its associated best practices, DBAs can navigate the complexities of modern database environments and deliver optimal performance for their organizations.